Okay, good evening. Welcome to
FamilyMath1074.
FamilyMath1074. So there's been a lot of talk over the last few days about fitting cubic equations to curves, and specifically to deaths from the coronavirus in the United States. I want to do a quick project with you tonight on cubics because it's kind of a fun calculus review, which you're in the middle of doing anyway. All right. So what is a cubic equation?
So it's an equation that whose highest polynomial or highest x power is x cubed. It's usually ax cubed plus bx squared plus cx plus d. That's how you write it.
Okay, great. What are some things we can say about cubic equations? I guess we have some room over here from looking at the camera.
Well,
or maybe you could sketch one, or sketch some general properties that you. It's not like we've spent a lot of time studying cubic equations, but what can you say about them? So
they have three roots. Sometimes the roots can be like together, so you could have just one root.
Okay.
I guess I'm not sure. Like they have. You can take the derivative of them; they're continuous.
Okay. What happens when you take the derivative?
So you'd get 3ax squared plus 2bx plus c. This is f of x. This is f prime of x.
Okay. So what can you learn from the derivative?
Well, your derivative is a quadratic. So I guess you can learn. So you can learn where, where it's increasing, where it's decreasing. You can find where it changes. Since the quadratic has two roots, the derivative changes sign exactly twice, or at most twice.
Okay, good. Yeah.
Sometimes it's just once, like here.
Okay. What about the second derivative?
Second derivative of double prime of x is 6ax plus 2b, which is a line.
Okay, and what can we learn from the second derivative?
So that tells you that your derivative is increasing and decreasing depending on which way you're going following a line.
Okay.
Anything
else?
At a linear rate. I guess the second it has exactly one inflection point.
Okay.
Second derivative changes sign exactly once.
All right. So what can we say then about the concavity of a cubic?
So the concavity is going to change once. So
okay.
In this one it changes right there, and in this one it changes right there.
Okay. Cool. Good job. That's nice. So why don't we talk about what you know a little bit about fitting curves. Because we've studied a little bit in linear algebra. So let's talk about what could happen fitting with a cubic.